In this video, I'll go over a question about the hypothesis testing, the p-value, and the test statistics. Let's take a look at this week 6 homework assignments for this particular problem. Our data set includes the data from 500 random tornadoes. The display from the technology available below results from using the tornado, the length, the miles to test the claim. So we are testing the claim that the mean tornado length is greater than 2.9 miles. Now use a 0.05 significant level, identify the null and alternative hypothesis, test statistic, p-value, and also state the final conclusion that answer the question about the claim, whether the mean is bigger than 2.9 miles. So anytime we are talking about the mean, we use the mu notation for the mean to represent the mean. So the mean is bigger than, is greater than. So this is greater than 2.9. And we know that in order for you to make the null and alternative hypothesis, anything without the equal sign that belong to the alternative hypothesis. And then therefore, your null hypothesis is the one that has the equality or the equal sign to 2.9. And we know that this is pointing to the right, and that should be the right tail, right? The right tail in this case. So in this problem, your null hypothesis is the mean equal 2.9 miles, and the claim is the one that has the inequality or bigger than 2.9 miles. So this one is the assumption for the null hypothesis. This is the alternative hypothesis. The next one is we are looking to find the test statistics. So how do I find the test statistics? Well, we know that in this case, we are not given any value for the standard deviation. So the standard deviation in this case is not given or unknown. And if your standard deviation is not given, is unknown, then we have to use the student t distribution. So we are looking to test the parameter, which is the mean in this case. The standard deviation sigma is not given, and the sample size is bigger than 30, so we can use the student t distribution, and the test statistic is t not equal x bar. This is the mean of all the sample minus mu naught over s over the square root of n. So the t statistic, the test statistics, is x bar. This is the sample mean, and minus the mu naught, this value right here, 2.9, is the mu naught value, divided by s. This is the sample standard deviation all over the square root of n. N is the sample size. Okay, so let's go back to the problem here. We know that the data set includes data from 500 random tornadoes. So 500 here is the value of the sample size n. This is the big data. And n is 500. So how do I get the value of x bar? This is the sample mean. And how do I get the value of the s, the small s? This is the sample standard deviation. So because this is a large data, we can use the StatCrunch in this mymathlab to help you for that. So now you can click on this icon to open it from the technology. Well, actually, it's already displayed for you all the value. So they got you the standard deviations, they got you the sample mean, they get you everything, even the p-value. So actually this problem is very simple. They give you all the value, the display from the technologies. So identify the test statistics, and the test statistic is right here, which is 2.73 if you round it to 2 decimal places. So 2.73, and then check the answer. And then the p-value is also given right here, which is 0.0033. Oops, actually they ask you for 3 decimal places. We have 1, 2, 3, 4. So let's use 3 only. So make sure pay attention carefully here. Okay, now the answer is given as the p-value, and we also know that the alpha, the significant level, is 0.05 in this case. When the p-value is less than or equal to alpha, then we reject the null hypothesis. But if the p-value is bigger than alpha, the significant level, we fail to reject the null hypothesis. In this case, your alpha is 0.05, and the p-value is 0.003, so that is less than or equal to alpha, the first case, and therefore you reject the null hypothesis. If you reject, that means you don't support the case when the mean is equal 2.9. That means you support this one. That means the claim of the mean to be bigger than or equal to bigger than 2.9 mile is good, right? Therefore, you reject the null hypothesis, and there is sufficient evidence to support the claim because the claim say is bigger than, right? The mean tornado length is greater than 2.9 mile, and then check the answer, which is correct. So basically this question is very simple. They give you the display or the results from the display from technology, and we just have to identify the correct values and put them in the correct spot, and also state the correct conclusions. Let's try another problem. Use the pulse rate in beats per minute of a random sample of adult females listed in the dataset available below to test the claim. So we are testing the claim that the mean is mu, is less than 78 beats per minute. Again, this one does not include the equality or equal sign that belong to the alternative hypothesis, and therefore the null hypothesis is when the mean is equal to 78 beats per minute. Right? And that should be C. Check the answer. And then next, determine the test statistic. Now for this question, again, we are given a list of the data. So we are not given anything about the standard deviation. So sigma is unknown. So sigma is not given, and there should be a large amount of data. So n is bigger than 30. We therefore can use the student t distribution again. The student t distribution. So the student t distribution, the test statistic, is equal to x bar minus mu naught. Mu naught is the value right here. This is mu naught over s, the sample standard deviation, all over the square root of n. N is the sample size, and x bar is the mean, the sample mean. So let's find the value of n. Let's find the value of x bar. Let's find the value of s. We can do that using the StatCrunch. Let's do this in this problem. So click on this here. So they give you the pulse rate beats per minute, right? Everything is here. You can open this data in Excel, in StatCrunch, but let's do it in StatCrunch. So wait for a few seconds so that it opens everything. And you can see that we have row 1, we have all the way down to 50. So there are 50 data value, or n, the sample size should be 50. Now the sample mean x bar, you add all of them together and then divide by 50. And then the sample standard deviation, you can use the formula for the standard deviation. But we don't have to do those by hand. We can just use the StatCrunch to help us for that. So go to Stat, go to Summary Stats, and click on Columns, because your data right here is the column. Now we are picking the post rate column, because this is the column that store all of your values. And then you just have to click the compute here. Make sure you select all the statistics that you want to compute, which is the sample size, the mean, the standard deviation, and so on. So click compute. Now you see that we get the value of x bar. This is the mean, 74.02. And the n is what? N is the sample size. They also give you here. In the case that you get a large amount of data, you don't have to count, scroll down all the way and then look for the number of the rows, but you just have to look at here and then it gives you the n right away. The sample standard deviation, the standard deviation is right here, which is 22.909. 21.909. So we have almost everything, right? So now it's time to plug in this formula. 74.02 minus mu naught. Mu naught is 78. The claim value over SS is 21.909 over the square root of 50. And I can wrap the TID4. And we can do that. 74 minus 74.02. After you plug them all in here, you should get negative 1.285 if I round it to 3 decimal places. Alright, this one is pointing to the left, right? The arrow. So in this case, it's the left tails. The left tail case. So how do I find the test statistic? Well, we just found that negative 1.285. They ask you only for 2 decimal places. So negative 1.80, negative 1.28, negative 1.28. Check the answer. And then lastly, they ask you to determine the p-value. Well, we know that in this case, let's do this by hand first. We know that this is the left tail because it's pointing to the left for the arrow. So if you draw the t distributions, okay, so we have the positive test statistic and a negative test statistic, one on the left, one on the right side, because they are symmetrical. Now the test statistic that we found earlier has the negative value, so I put the negative value on the negative side, and we are looking for the left tail. Therefore, I'm looking for the area of the left of the tails, right? The left tails, and the area of the whole left tails here is the value of the p-value. So to find the p-value, we are looking for the area of the left tail. So p-value, we are using a function called, this is the student t distribution, so we use TCDF. So TCDF, so go to second var distribution, we go to TCDF, the option 6. Now because we want all the way from the left, right? So the lower bound is all the way from the left. So I put a very a negative value, 99999, a very small value on the left side, and we go all the way to the upper bound, which is this value right here, or negative 1.285. And then the degree of freedom is n minus 1, right? N minus 1. In this case, your n is 50, so we have 50 minus 1 of 49. And if you do that, or you're gonna input the lower bound, the upper bound, and then the degree of freedom n minus 1. and then just click enter, and that is your p-value, which is 0.102. So 0.102 is your p-value. Okay, let's try to put that in here. They want you to route 3 decimal places, so 0.102. 0.102, and that is correct. And now let's make the final conclusions. Alright, again, we make the conclusion based on the p-value. If the p-value is less than the alpha, less than or equal to alpha, we reject the null hypothesis. If the p-value is bigger than alpha, we fail to reject the null hypothesis. In this case, your alpha is 0.01 and p-value is 0.102. This is bigger than 0.01, which is the second case. So we fail to reject the null hypothesis. So fail to reject the null hypothesis. If we fail to reject the null hypothesis, the claim is saying that is wants the mean to be less than, right? Less than, so they support the H1, but now we fail to reject H0. Therefore, there is not sufficient evidence to conclude that the mean of the population of the post race of the adult females is less than 78 bits per minute. Check the answer, and that is correct. Okay, so we was able to finish everything by hand, but now we can also use the StatCrunch to help you to find all the value, the p-value, the test statistic without any calculation by hand. So the first thing is we're gonna open the StatCrunch again, and we're gonna go to Stat. In this case, we're using the student t distribution, so we look for the t statistic. This is only one sample, so click on one sample, and with the data, so you want to input all of your data, which is this column. This column is the post race, right? This column, and you want to put the hypothesis test for the mean. The mean in this case, again, your mean is right here, and you are looking for the mean equal to 78. That is your null hypothesis. For the alternative hypothesis is less than 78. And then we also define the you're gonna select the optional graph and the table if you want to. If not, it's fine. We just want to have the value, so it doesn't matter. You don't have to select anything here. So let's just click compute. So they give you the p-value 0.102, which is what we found right here. And at the test statistics, negative 1.2845, which is right here. So the same thing, right? You can get the value from StatCrunch just with a few clicks, or you can do it all by hand using the formula that we learned from the lectures. So either way, you still end up with the same conclusions, the same values at the end. Thanks for watching.